In question 1b, we're asked to solve the equation by factoring, and we can factor this one because it is the sum of two perfect cubes. So we're going to take the cube root of 8x cubed, which is 2x. We're going to take the cube root of 1, which is 1. So that gets our factorization started. Now we take the first thing and square it, which is going to give us 4x squared. We subtract the first thing times the second thing, which is 2x times 1, so minus 2x. And then we add on the second thing squared plus 1. That was the factorization patterns that we've been working on throughout the unit, and also that you practice a little bit on prior to the quiz. So now once we have these factored, we have basically two numbers that are multiplied together that give you 0. So as soon as we hit this, we know that whenever we multiply two numbers together, we get an answer of 0, that one of these numbers must be equivalent to 1. So 2x plus 1 must be equal to 0, or the other option is that our 4x squared minus 2x plus 1 equals 0. So we start operating off the simple premise that numbers multiplied together give you 0, that one of these numbers must be 0. The first number that we're looking at is a linear factor, so that means we can solve for x by simply isolating x. So that means we can subtract the 1 and then divide by 2. So one of our solutions that we're looking for is negative 1/2. The other two solutions are going to be a little bit hard to find because they're locked up in this quadratic equation. In order to solve this for x, we're going to have to apply our quadratic formula, or we could attempt factoring. There are really two choices that we're going to apply. We can either factor, or we can apply our quadratic formula. But just a quick look at these numbers, 4 and 1, to end up with a negative 2 in your middle, outside, inside. That's not going to work very well. So I'm going to quickly go to the quadratic formula. And this means that we can find our zeros, our x values will equal the opposite of b, so positive 2 plus or minus the square root of b squared, which is your negative 2 squared, which is 4, minus 4 times 4 times 1. So it's really, since it's a minus 4, it's a negative 4 times a positive 4 times a positive 1, which is negative 16. That's all over 2 times a, which is 2 times 4, which is 8. So we're going to simplify by chugging out a little bit more of our expression. 4 minus 16 is a negative 12. And we're going to divide that by 8. And then what we want to do is we want to simplify our radicals. So at this point, I'm going to break up the division. So I'm going to distribute the division by 8. I'm going to take the square root of a negative 12 and be thinking of it over here as, this is the square root of 4 times 3 times I. The reason 4 is a good number is it's a perfect square. So we're trying to find perfect squares that divide into 12. And that means I can simplify this to 2 times the square root of 3i. So this square root of negative 12 becomes 2 times the square root of 3i all over 8. And now we want to reduce those fractions. So that means x is equal to 1/4 plus or minus square root of 3/4 I, because our 2's were reduced with the 8's. They can give us our simplest form of our answers. Now there's the other two answers that we were asked to find. Total of 3 for a cubic function.